Well, thank you very much for this invitation. I've been looking forward to participating, and as I've had time, I've listened to some of the other presentations. It's delightful to be able to participate in your conference remotely. That's just great. So let's get started. Um, so yes, as Simon said, I'm Mike Heroux at Sandia National Laboratories. In this particular role, I'm the director of software technology for the U.S. Exascale Computing Project. And I'm going to talk with you about E4s, the Extreme Scale Scientific Software Stack, which is an effort that is sponsored by ECP, the Exascale project. But we have much broader hopes for it. And part of my excitement in speaking with you today about it is the opportunity to show perhaps collaboration points with E4s. So let's get started. Whoops. All right, went a little too far. You're probably all very aware of the exascale landscape. We have Perlmutter coming online at NERSC. Aurora and Frontier are coming soon. Also in the National Nuclear Security area, Crossroads and El Capitan. Not on here is ARM, especially with SVE, the scalable vector extensions, but I wanted to point out that within the same code base about which I'm speaking is effort to support ARM and SVE. And so growing up alongside of the efforts that we have for GPUs is underlying support for many core processors with vector capabilities. ECP is organized into 3 focus areas: application development, which has roughly 24 applications. These are kind of the blooms on the flower that allow us to do really neat scientific and national security and data types of applications. Underlying that is sometimes I think of ourselves as ST as the plumber to make things happen underneath, and that's software technology. In addition, we also have hardware and integration. This particular team has very nice relationships with the vendors and with the US leadership computing facilities, and they facilitate interactions for AD, the applications, and the software technology areas, and they're really critical to our efforts. I'm going to talk about software technology. So ECP-ST has 6 technical areas. 4 of them are functional in nature: programming models and runtimes. Hal had mentioned quite a bit of the work that's going on in this area. It's very nice segue to this effort. And then development tools. Hal also mentioned things. We recently reorged software technology, and the development tools technical area is organized around LLVM. As we saw that a number of projects are contributing to LLVM, we needed to have better coordination of our contributions to this stack. Math libraries, these are things you may be familiar with: PETSI, SuperLU, Trilinos, the dense linear algebra work at the University of Tennessee, FFTs, things like that. Data and visualization are things like Paraview, and now what the Alpine project, and we just recently brought in Sensei, an API for in situ data analytics and visualization. So those are the 4 technical areas. And then the software ecosystem is all about how do we deliver our capabilities. So everything is done as open source. The vast majority is on GitHub or GitLab platforms. But then how do we get it out there? And so this is where we fund efforts in SPAC, the software meta build system, container work for HPC systems, and a lot of our software quality initiatives are driven out of this software ecosystem area. And then in this recent reorg, we also took the NNSA, that's contributions directly funded by NNSA at the Lawrence Livermore, Los Alamos, and Sandia. and put them into a single technical area so that we can have a better coordination of those activities within ECP and within the labs themselves. And so a lot of the efforts going on in the 6th column cut across the other areas, but it makes sense for our management purposes to put them into this spot. Just briefly, these are the people that are involved in leadership. Myself as the director, Lois Kerfman-McInnes is the deputy. And then I'm guessing you probably know at least a few of these names. We're very fortunate to have a senior team of people who have been in this business for a long time to guide the activities of software technology. Briefly, we're organized into 33 level 4 sub-projects in the hierarchy of ECP. Not to go any detail, but just so you could sort of see, it's a leave behind slide. One of the things I do want to point out is, in addition to having a PI, we have what we call a project coordinator, and this person is responsible for making sure that the things that are required to be done by a certain time in a certain form get done. And prior to this recent reorg that we did last year, we didn't have such a role, and it was very hard. Some of the PIs, they excel as PIs, but not in this process-oriented activity. And so we created this new role. In some PIs, we allowed them to play both the PI and PC role. Some PIs, we said, you may not be the PC. You're really bad at it. And that has actually really helped a lot. And even some of the PIs who are good at it eventually decided, it'd be really nice to have somebody else do this. And then you may also notice in the name list of the PCs that some names appear more than once, which is also really nice. It provides us with amortization across groups, because the same requirements are often made of all the groups at the same time. What do we work on? You'll see just here, lots of things that you know about. We make significant contributions to MPI, both in terms of software and MPICH and OpenMPI, but also in terms of the standards, OpenMP and OpenACC. Even though OpenMP is the official marked-up-based parallelism, we still keep some effort going on in OpenACC. I can go into details later if you want, but there are some really important reasons why. Hal mentioned Cocos and Raja, and the LLVM performance tools. Depending on which community you're a part of, you may know these tools really well or not at all. It seems to be a very stark contrast in exposure to PAPI, TAO, and HPC toolkit. Math libraries I mentioned, and then HDF5, MPIO, and audios, and then all the data and viz pair of view related capabilities. So let's talk a little bit then about the Extreme Scale Scientific Software Stack, E4s. It is a collaborative HPC Linux ecosystem, in a few words. So ECP didn't enable in any fundamentally new way the development of individual products. So MPICH, OpenMPI, the math libraries, all of that work was going on long before ECP, successfully being delivered to the next leadership platform. And so that is not really different. What ECP provides for us is the ability to add some coordination layers on top of these individual projects to create two additional organizational structures. One is software development kits. This work actually started before ECP, but is now expanded. So SDKs, as we call them, are collections of similar products. We started first with the math library some years ago, the so-called XSDK, which is a collection of math libraries. And the agreement being that the community of math library developers would have a set of common community policies, be able to build against each other's software with explicitly named versions and coordinated versioning. And then overall get to know each other and each other's capabilities, do coordinated training, coordinated testing, so that we can build value and build the user experience with a little bit of extra effort versus just the independent development. Now, each team continues to do its own development work, continues to make its own decisions about algorithms and direction of the project overall, but it's now done in a coordinated fashion, a kind of federated system. On top of that, we build E4s, which is this the potential for everything, but it's also, I'll show you a bit a la carte as well. But this aggregation of all the capabilities, the SDKs as we build them up, but an entire HPC Linux stack, including even now some of the AI machine learning, TensorFlow and supported capabilities. And so these are the new layers that ECP provides for us, because we're a multi-institutional project, and so we can coordinate activity across what were previously independent projects. This is just the components of ECP. It's a curated release of products. We have 50 of the 70 already part of it. We have a number of targets that we support. We do a lot of work in containers, and we're building up a tool set that is also very useful for doing things like MPI launch and things like that. We have a doc portal that I'll talk about. A lot of different activities going on related to E4s to provide its capabilities. We've done 4 releases. The first one was in October of 2018, the most recent in February 2020, and we continue to make progress on including the products that are that ECP contributes to, as well as a whole bunch of other things. This is just a list of the things. I won't go into detail. Let's see, and then so that's a little bit about E4s. I mentioned the software development kits. What we do is we try to group products that are similar in capability, similar domain scope, interaction model, and create policies, and bring groups of people together who are, in a sense, competitive with each other, right? The math software groups are competitive with each other, and we're adding a layer of cooperation on top of that. So we call it co-opetition, as a term that we use to describe it. And it's led to some really nice exchanges and positive improvements in this math software ecosystem. And we're trying to bring this to other areas. This just shows you the growth in the math software area. We started with 5 math libraries in the beginning, PETSI, SuperLU, Trilinos, and a few others. And then over time, it's grown. So now there are 23 math software libraries that are XSDK compatible. It means that they subscribe to the policies, quality policies that we have, and it means that they're compatible. It doesn't mean you have to build them all, but it means if you build all of them or some portion of them, your experience should be much easier, because we do planning and testing on a regular basis with each other's code. And it's this horizontal grouping that's really one of the most important things that's come out of this. PETSI and Trilinos are both frameworks. We both use SuperLU underneath. We never collaborated on the version. And so now what the XSDK does is it forces this horizontal grouping and improves the user experience as a result of it. We now confirm with each other which version of SuperLU we're using, so that we're both using the same one. I mentioned policies. These are essentially the contract between the library developers and the users, and the library developers and themselves. They're quality metrics, and in fact, these have become the entrance criteria if somebody wants to join the XSDK. These are the specific items that need to be addressed positively in order for someone to join the XSDK. So we've now extended this SDK concept to the entire ECP software technology stack. These color-coded blocks are the other SDKs. And we've continued to make progress in forming communities around these products. And we have support within ECP, funding support for these teams to work with each other. This summer, we've initiated a SDK policy effort, so that each SDK community has developed its own initial set of policies, similar to the math libraries one, but not always the same, And then we're going through those now to analyze which policies should belong at the E4s level, at the very high level, and which of them are peculiar to the SDKs themselves. And we expect to have this version 1 of policies out by the end of the year. I also want to mention the doc portal, documentation portal. This is a single portal to redirect to product documentation. One of the biggest requests we have from people at our facilities is they want to know, how can I get access to documentation? How can I know who to contact if a user has a bug? What platforms does a given product support? And so what we're trying to do is build an infrastructure that will allow teams to put in their repositories this kind of information in metadata files. README is the most obvious one, but there's also license file. There's also collaborators. There are lots of different metadata files, and we want to identify those and then be able to rake information directly from the repo on a regular basis, every day, a couple times a day, and then cache that data on a local server or for web services, and then provide that to the user base. And so this E4s doc portal is exactly that. We have a prototype available at the link that's there below, e4sproject.github.io/doc portal. And if you go there, you'll see this page, which is just simply a list. We're not web designers. We're going to start working with professional web designers to make this nice and polished, make it searchable, sortable, and all that kind of thing. But fundamentally, what we're doing is raking information directly from the product web or repos. And we believe this is the best place for the most up-to-date information. And if the information isn't up to date there, it should be. And so we should have an expectation that teams will keep that information up to date so that we can rake it and other people can have access to it. So just as an example of what you do, so let's say you want to pick a particular product, ParallelNet CDF, you select that, and then you get the local cache, and it's just a few lines from each of the files that are present in the repo, and we'll grow the number of files as we mature the process. And then if you select one of the more items, then you'll go directly to the repo and get all the detail associated with the information that you wanted. And so this allows people to quickly get access to things that are part of E4s. And we anticipate expanding the doc portal to any team that wants to participate if they can provide some quality. And this is where the community policies come into play, is making sure that we're pointing to quality products as we do this effort. The status of this is we've done a prototype and design, and we're deploying the first version of this. I just want to mention briefly that E4s is available from source. We build it using SPAC, but in many other ways. We've invested in GPU images, Docker, Singularity, and all of this is available from e4s.io, and also on Docker Hub and a variety of other sources. There's so many different ways. You can go to e4s.io to get all the details. We've also invested in build caches and container build pipelines. Again, there's a lot of detail on the e4s.io website, but we have a SPAC build cache at the University of Oregon right now that has over 10,000 binaries. And so if you link yourself to this build cache and there are signatures in the build that the build cache is captured, you don't have to build that, and you can simply pull that in and dramatically reduce the build times of your application. We're working on a new website, official website for this to kind of support as well. Just to give you briefly an example, WDM app has recently adopted E4s as a way of building itself. WDM app has many third-party dependencies, and you can use the E4s WDM app Docker container to dramatically speed up the build of WDM app, and like orders of magnitude in some instances, and by using these caches. So I wanted to mention that we're not starting from scratch. We didn't emerge from nothing. We're leveraging the work of many other people long before ECP existed, in particular HPC Linux, which was work done at the University of Oregon and at Paro Tools. The XSDK math libraries originally started before ECP, and then SPAC, of course, predates E4s. So we're taking these really mature capabilities and efforts and growing them across the entire stack and giving them more visibility as we go forward. So just a summary of what E4s is and is not. It's not a closed system. We welcome contributions from elsewhere. We, in fact, absolutely need them. It's not monolithic. It's a full collection, and it's a manifest of capabilities. It's not a commercial product. We're not going to compete with anything. What we're doing is we're a community of developers who are producing scientific software, and we want to have an effective and efficient vehicle for getting that software out to others, including vendors and facilities and collaborators, so that our work can be more effective and efficient in general. We're not simply a packaging of existing software, especially with the SDKs. We're doing a lot of development, and we're folding that into what E4s provides, and then testing it on a regular basis on the leadership platform. I want to mention briefly E4s Collaborations, because I think there are opportunities here with the UK. So this is just an indication that we've had workshops with NSF. We are regrouping this summer. We were planning to have one at TAC, but that had to be postponed. But we have strong interest from NSF. We've had numbers of deep conversations with other US agencies and the UK, and we're intent on creating collaborations with international institutions as we go forward with E4s. I think it only makes sense that we collaborate together. So we already have in our software stack Deal 2, which is NSF funded. We have FIS, which is a library from German Aerospace as part of the XSDK. We interact with OpenHPC, the HPC system vendors, the facilities, and then other organizations, as I mentioned. Here are some potential UK ECP collaborations. Again, I don't want to go into too many details, but you can see on this list, and we've had conversations already with people from the UK HPC community about these things. And I see that there are a number of opportunities for collaboration. Okay, so a bit of a summary. So E4s is a curated release of complete software capabilities. We're putting our latest ECP developed features into this stack. They're ported and validated. We do regular testing with validation tests. We have a single doc portal access to all the product documentation. It's in prototype mode, but it's going to be available increasingly for all products. We care a lot about collaborative development communities using these SDKs, policies, and then making our software available. Really what I think E4s is, it's a new member of the HPC community. It's a managed portfolio of HPC software teams and products. We have first-of-a-kind collaborations going on, first-of-a-kind discussions with the vendors, facilities, other agencies, US and industry and internationally, that we weren't able to do before because we were just a independent set of independent projects. Now, as a portfolio, we are large enough to have conversations that couldn't occur before. It's extensible to new domains. As I mentioned, we already have support for TensorFlow and other machine learning software. There's no fundamental impediment to growing the domains to which ECP and E4s can be applied. And I think it is a new way of delivering reusable HPC software. I'll leave you with a pointer to our capability assessment report. It was released in February, which only seems a few weeks ago with the pandemic, but it's been several months. You can find out high-level information about the software technology area, E4s, and then glimpses, a couple pages of each of the projects within software technology and what they've done, what they're doing now, and what they plan to do next. And I'll stop here and take any questions if there are some. Thank you.
Thank you, Mike. That was absolutely brilliant. There's some really, really interesting things in there, and some things I wasn't already aware of, things that have happened more recently, I think. and certainly plenty of opportunity for collaboration. I think you highlighted lots of really good things. And we said early on that in the UK, we shouldn't be trying to just reinvent wheels, and there's obviously a lot of opportunity there for some really interesting collaboration. So thank you very much for that.
Yeah, my pleasure. Yeah,
thank
yeah.
you.
Great. Thank you for the invitation.
Great. There have been a few questions coming in. I think we've got time really probably for one or two. The first one was about MPI, and maybe MPI is starting to show its age again. And are you aware of any of the sort of specifics about how MPI has been evolving and developing to make it more sort of ready for exascale?
Yeah, sure. At a high level, I'm afraid I'll frustrate you if you ask me for details beyond what I'll just describe here. I was just telling someone earlier today that I wrote software for many years, and I wrote software by email and phone calls, and now I talk to people who write software. But I still try to stay up to date if I can. So that some of the latest features that are going into MPI are, overall, I think the MPI community has had competing models for how to do the plus of MPI plus X. And actually, Hal probably can speak to this better than me if he's still on, but he might not be. But the latest work has been in resolving some of these differences in the plus. And so I think the community as a whole has a much better handle on how to coordinate MPI processes on top of threaded parallelism, block thread parallelism. So that's one thing that's been I think a real improvement over time, is there's much better clarity around the model, what I would call an execution model for MPI plus X. The second thing that's going on is there's been a lot of work going on in reducing latency of MPI when executing on GPUs. This is a huge problem. It will be a fundamental problem just because there is so much latency relative to how fast these GPUs work. But there's been a lot of progress made in stamping down that latency, and that is fundamentally a strong scaling issue, right? You simply cannot scale and use a lot of GPUs if you can't get that latency down. And so there's been quite a bit of progress made in both of those areas. And it's been both by OpenMPI and MPI-CH, and that's why we really need to support both of these communities in their efforts. They bring different value propositions to the ecosystem. So I'm sure that's not a satisfactory answer, but that's as best I can do.
Great, thank you. Maybe time for just one more. So there's a question about HDF5 and it's struggling to maintain its MPI features. There's just a PhD student looking after that. And I think the question is, can or should the ECP project sort of take control of that or help contribute with that? Is that the kind of thing that might come into ECP in the future?
I can just speak in general about HDF5. ECP has steadily increased our commitment to HDF5 in two ways. One is we are providing substantial funding to the HDF group and also to Lawrence Berkeley Lab, where there's strong collaboration, and then other places as well, but those are the two big development groups. So there are two aspects. That's one aspect, and so we continue to provide additional funding to them because our users keep coming back and saying HDF is the interface we want to use and the underlying implementation. In addition to that, this is actually through the SDK efforts. We have been providing funding for other I/O libraries to provide their capabilities through the HDF5 API. And so that if someone is invested in the HDF5 API, they can more readily switch to using something like Audios, for example, and use it as a side-by-side comparison. And that's not to say that we distrust the HDF5 native implementation, but in general, when you have an ecosystem, it's good to have practical standard APIs that allow teams to try different approaches, much in the way we do with MPI. We have, multiple MPI implementations underneath the standard interface. We're promoting that same concept in the I/O area.
Great, thank you. There are a few more really interesting questions, but we're we're just out of time. So what I'll suggest is, if you don't mind, Mike, if you're happy to reply to the remaining questions, just sort of via text. I think you can do that in the Q&A
Yeah, in the chat
box in the chat. That would be great.
Sure, happy to do that.
Again, very much, and thank you for joining us sort of early in the day. We really appreciate it, and thank you for the.
Oh, my pleasure. It's yeah, it's been great. Thank you very much.
We're going into a break now, so we're going to restart at 15 minutes past the hour, so 4:15 for those of us in the UK. So go and get another coffee and stretch your legs. Hang around if you want to keep asking questions, and we will restart at 4:15 with our last talk of the day, which is from Codeplay, and it's going to be about sickle, which is something we've been hearing a little bit about.
Yeah, very good.
So, thanks again, Mike, and thank you, everyone.
Yep, thank you. Yep, bye-bye.
Thank you.